In the previous lecture, we learned that using this command right here will add a registry entry that will start a program called test.exe that's stored in C every time the system starts. So now, to make any Python program persistent and start with the system startup, all you have to do is use subprocess.call and execute this command, and just make sure that you replace this with the name of your program after converting it to an exe. It's literally as simple as that. But that's going to be a very buggy implementation. This implementation will have two issues. First of all, now our program, the backdoor, if you converted it to an exe using this command, using the one file and no console argument, and then you execute the program without listening for connections. So you can see here, I'm not listening for incoming connections, and I'm going to execute the backdoor. You will see that I'll get an error message. Basically, this error message is shown because the backdoor is not able to connect back to me, to the listener. So the first thing that the backdoor does is it tries to connect. If it couldn't connect, it's going to show this error. Now, if you execute this command is going to execute your backdoor every time the system starts. And if the system starts and executes the backdoor and the hacker is not listening for incoming connections, the user is going to see this error message, which will make them very, very suspicious. Now, luckily, this can be very easily solved using something that we learned already by literally just wrapping this in here in a try. So we're going to try to do all of this, and we're going to accept any type of exception. And if this happens, we're going to exit the program. Now this way, if for any reason the backdoor was not able to establish a connection, it will not show an error. It will simply exit silently without showing an error to the user. So if the program starts with the system startup and the hacker was not waiting for connections, the user will not see any errors that will make them suspicious. Now the other issue that I'd like to address is, as you know, for this to work, you have to specify the name of the executable in here. Now if the user deletes, or even if they decide to move the executable or the file that they downloaded to any other location, this will not work. So a very good idea is to make a copy of this file somewhere where the user probably will not see, and then add a registry entry that will run the copy of this file, which is stored in a hidden location. So let's put this in practice. First of all, I'm going to create a new method, and I'm going to call this method become persistent. Now inside this method, the first thing that I'm going to do is specify a location where I want to copy my evil file to. So we're going to say evil file location is equal to, and you can set this to anything you want in Windows. I like to put it in the app data directory. So this is a default directory that's there in all Windows operating systems, and it's usually in users, followed by the user on this computer, followed by app data, followed by roaming. Now, as you noticed, this right here is a variable depending on the username, but there is a nice way in Python to get this directory, which is using the OS library. So let me show you. If I just run the python.exe and import OS, and then if we do os.environ and give it app data, and I misspelled environ, as you can see, it's going to give us the location of the app data directory. Now OS is a library that we dealt with before, and environ allows us to get environment variables. So the environment variable that we're asking for is the app data, and Python is giving us the location right here. So we can use this in our code, and we're saying my evil file location is going to be equal to os.environ, and we're going to get the app data, and this will be followed by the file name. Now make sure you put 2 backward slashes before the file name. That's the way that Windows separates files and directories and paths, instead of the way that Linux does it using a single forward slash. So in here, again, you can call your file any other file you want, but it's nice to use a name that will not be suspicious. So a good idea to call it Windows Explorer, for example. Okay, now the next thing that we want to do is copy our current file, the backdoor file, the file that we're running from right now, to the evil file location. Now to copy stuff in Python, we can use the shutil library. So you can see that I've already imported it in here. And then we can do shutil.copyFile. The first argument is going to be the source file. So this is the current file that we are running from. And since this is going to be an executable, we're going to do sys.executable. If we were running this from a .py file, then we can just replace this with __file__. This will refer to the current Python file. But since we're going to convert this to an exe, we're going to refer to the current file as sys.executable. So we want to copy the current file to the evil file location. Once we're done with this, we're going to do subprocess.call, and I'm going to add shell is equal to true. As usual, we've used this a lot before. And the command that we're going to pass, I'm going to use single quotations for the command. And the command that we're going to use is exactly this command right here. So I'm going to copy all of this and paste it here. And after the /d, as we seen in the previous lecture, we have to specify the location of the file that we want to execute. And right now the location is the evil file location. Now, since this contains spaces in the name, I'm actually going to wrap this with double quotes. And keep in mind that this will not interfere with my string because I'm actually using single quotes now to quote my string. So I'm going to open a double quote in here, and then I'm going to append my evil file location, and then I'm going to append another string which will literally just contain my double quote to close the path in here. So basically we're using these quotes right here before and after the variable so that whatever path we're specifying in here will be surrounded by double quotes, just like we did when we used the command from the Windows command prompt. So let's have a look on what we're doing so far. First of all, we're setting the location where we're going to copy our evil file. We're setting this to the location of the app data directory, followed by the file name that we want to rename our evil file to, and we're going to rename it to Windows Explorer. Then we're copying the current executable, which is the current file, which is going to be the evil file, to the evil file location that we set in here. And then we're executing a system command that will add a registry entry that will execute the file that we have in the evil file location. Now, our goal is to execute this piece of code every time the system starts, which means that this part right here will be done multiple times every time the system loads. So it'll be a good idea before starting to copy this and add in a new registry entry to check if there is an evil file in this location. Because once we do this once, we don't need to do it every time the program starts. We only need to do it once and that's it. It's planted in the system. So what I'm going to do, I'm going to add an if statement here. And I'm going to say if not os.path self.exists for the evil file location, then I want to do all of this. So basically what I'm saying is, if the path that I'm specifying for the evil file location, which is this path right here, so if my evil file does not exist, then I want to copy the current file to the evil file location and add a registry entry to run this on the system startup. Otherwise, we won't execute this code. This means that this code will only get executed once and won't be executed every time the system loads. Now our method is done, and all we have to do is call it somewhere from our backdoor. Now we know the code in the init, in the initializer, gets executed before anything happens, before any other piece of code. So it'll be a good idea to become persistent before we do anything, before we even establish a connection. So we're going to call it from here. We're going to say self.becomePersistent, and then our backdoor is going to try to establish a connection and do all the stuff that we know. So now we're done. Let's compile this. So we're using the exact same command that we always use. I'm going to hit enter. And now I'm going to transfer this to my Windows machine that does not have a Python interpreter installed. Okay, so now I have the backdoor in here, and you can see it says number 1 here because this is the new one that I just downloaded. And now if we double click this and notice that I'm not listening for incoming connections here, I'm just gonna double click it and we're just gonna say run it anyway please. You'll see that we're not gonna get any errors, which is great. But if we look at the registry in here, and I'm just gonna refresh the run, you'll see that we have a new entry that will run a program stored in IE-user, AppData, roaming, Windows Explorer.exe. So it's not very suspicious. You can see that Windows is running something called OneDrive anyway, and it's also stored in the AppData. So if I minimize this and let's just go to the AppData and make sure that the file exists there. So if we go to this PC, C, users, IE-user, you'll see that AppData is a hidden directory. You can't even see it. So we're going to have to go on view and tick the hidden items to show the hidden items. We're going to go inside AppData. We're going to go in roaming. And as you can see, we have the file here called Windows Explorer. So let's close everything and restart the computer and see if the computer is going to connect back to me by default. So I'm just going to go in here and I'm going to clear the screen and run my listener. And let's just watch in here while Windows boots and see if we get anything suspicious. Now Windows is starting. I'm going to log in. And as you can see, we get a normal login. Nothing popping up, nothing scary, no error messages, no command prompt windows. But if we go to the Kali machine, you'll see that we got a connection. So now we can do dir to list directories. We can do cd to see our current location. We can do who am I to see our current user. And right now we managed to get our connection back by planting our backdoor in the target system so that every time the system starts, it'll execute our backdoor. This way we're going to maintain our access to that system, and this method can be used with any other Python program or with any other evil file. Like I said, if you use it with the keylogger, you'll be able to always spy on your target. If you use it on the execute report scripts, you'll always get your reports, and so on.